This is Finding All Zeros Take 4. I am having huge technical difficulties, but what do you, when Plan A doesn't work, what do you do? 25 more letters in the alphabet. Sean, are you with me? Santi, Yusuf, Jesus, Mark, Lexi, Casey. Janelle, should I use my dancing parenthesis hands? Okay, forget it. Let's get to work. All right, we've got to find all the roots. I can't factor this thing. It doesn't have a GCF. What do? I use the possible roots that we learned how to do yesterday. And this is where I take factors of 6 and divide it by all the factors of 1. Well, anything divided by 1 is itself. So my factors are positive and negative 1, positive and negative 2, positive and negative 3, and positive and negative 6. Once I have this, I'm going to test these. I'm going to test these roots. I'm going to test these roots with synthetic division. And I know this. I know that if my remainder equals 0, what does the remainder theorem say? Then that value is a root. All right, so we're going to try x equals 1. We're going to try x equals 1. It's right here. I'm going to list the coefficients in standard form of my polynomial. I've got a 1, a negative 7, a positive 17, a negative 17, and a positive 6. I'm going to drop my 1 down, and that gives me a 1 to start. I multiply, bring my 1 over. That gives me a negative 6. I multiply, and I get a negative 6. I add, and I get a positive 11. I multiply, and I get an 11, and I add, and I get a negative 6. And I multiply, and I get a negative 6. And I get a remainder of 0. I am the happiest person in the world. See that? Yay! What this means is x equals 1 is a root. So now that I have that, I need to keep working and find additional roots. But I'm not going to work with our original equation. I'm going to work with this new equation that we have right here. So I'm going to do this all over again. I'm going to repeat this process. Only I'm going to use, remember this was an x to the 4th? Well, when I divided out an x, this is an equation in x cubed. So I get x cubed minus 6x squared plus 11x minus 6. I'm going to do the same thing, and I'm going to find all the possible roots. Well, this is just a repeat of our earlier where we started. Here's a 1, here's a 6. So my roots are the same thing. 1, 2, 3, and 6. Okay? So we're going to start. We're going to try another value from this list. And since I had such really good luck with x is 1, I'm going to try it again. So I'm going to try x equals 1, only my coefficients are coming from this equation here. So I get a 1, a minus 6, an 11, and a minus 6. All right. Here's synthetic division. Drop it like it's hot. Multiply. Add it. Multiply. Add it. Bring it over, and I get a remainder of 0. I am so happy. This means that x equals 1 is a root, and in fact, it's repeated. We're going to write it twice. Notice it shows up twice. Okay. Am I completely factored? That's what you're going to ask yourself. Am I completely factored? Well, I'm not. I know you're sad. This was an equation in x cubed, but when I divided out an x, this is x squared. So I'm going to write this equation as 1x squared minus 5x plus 6. And I'm going to see if I've got other tools in my tool belt to factor this. Do I have two numbers that multiply to 6 that add to a negative 5? And would that be What numbers are those going to be? Is that going to be a 6 and a 1? Or is that going to be a 2 and a 3? So two numbers that multiply to 6 that add to negative 5. I think they're going to be a 6 and a negative 1. Ooh, that's not going to work. That's going to multiply to a negative 6. So I can't use that. So I'm going to back up here, and I know what it has to be. It has to be a negative 2 and a negative 3, because those multiply to a positive 6, but they add to a negative 5. So I can use the shortcut here. I can say x minus 2 times x minus 3 equals 0. I can set each one of those equal to 0. Solve for x. So I get x equals 2. I get x equals 3. And don't forget, I got x equals 1 earlier. I got x equals 1 earlier. X equals 1, doesn't that guy have a multiplicity of 2? Do I have 4 answers here? I do. I'm really, really, really happy. I'm going to do a yippee. Okay? That's how we find all the roots of a polynomial. Let's work through one more example for you. Okay, what are all the zeros of this guy? Well, remember, to find the possible, I have to do the factors of 6, which are 1, 2, 3, and 6, all over Q, all over the number 2. So that's a 1, and that's a 2. So my list of possibles is going to be pretty big here. My list of possibles, I'm going to take 1, and 1 can be written over 1, or it can be written over 2. Then I'm going to take the number 2. 2 can be written over 1, which gives me 2, or 2 can be written over 2, which simplifies to 1. Now I'm going to take 3. Well, 3 divided by 1 is always 3. 3 divided by 2, though, that's 3/2. I'm going to leave that there. Last but not least, 6 divided by 1. And 6 divided by 2 gives me 3. He's already there. So these are my possibilities. Now I'm going to go through and I'm going to start checking. So I need to be careful. I'm missing an x squared here. I'm missing an x squared. So we're going to add it in when we put our long division out there. Also, who do you want to check first? I would probably check x equals 1 first. X equals 1 or x equals negative 1 is an easy way to go. So I'm going to put the number 2. I'm going to put the number minus 3. I'm going to put a 0 for my x squared. I'm going to put a minus 1 and a minus 6. And now we're going to start the synthetic division process. So we're going to drop it like it's hot. We're going to this is a 2. Multiply it. Add it together. This is going to give me a negative 1. I'm going to add it. A 1 and a negative 1. This gives me a negative 2. So 1 times negative 2 is negative 2. This is negative 8. So x equals 1, not going to happen. All right. So let's try x equals negative 1. So now we're going to check. And notice I'm saying check, so I don't get myself confused. We have a 2, a negative 3, a 0, a negative 1, and a negative 6. All right, let's drop our 2 down there. We get a negative 2. Let's add them. We get a negative 5. Let's add them. We get a 5. Here we get a negative 5. That gives me a negative 6. Oh, I'm happy. That's a positive 6. So I have a remainder of 0, which means x equals 1 is a root. How am I going to remember? X equals 1 is a root. Okay, so we are not done. This equation was a degree 4, so we've got to look and we've got to start all over again. So since this was an x to the 4, this equation is an x cubed. So we're going to write down 2x cubed minus 5x squared plus 5x minus 6. And we're going to have to go start all over again and look at all those possible roots. So my possibilities, they're going to be my same list as before. So I still have a 2 and a 6. So my same list as before is right up here. Okay, so I'm going to try with a positive 1 again. I'm going to try him here. I'm going to try him here. So we're going to try x equals 1. I'm going to write over here, same as in step 1, because we have the same constant and leading term. So let me write down a 2, a negative 5, a 5, and a negative 6. Let's drop it. Let's get a 2. Let's get a negative 3. Let's get a negative 3. This is going to give me a 2. That's going to give me a 2. That's a negative 4. Okay, so x equals 1 doesn't work. Does not work here. So let's try x equals a negative 1. So I'm going to put in a 2, a negative 5, a 5, a negative 6. Let's drop it. That's a 2. Negative 2 gives me negative 7. 7, that gives me 12. Negative 12, that's a negative 18. So x equals negative 1 doesn't work. Okay, what's up? Let's go try our next factor. Let's try x equals 2. So if I put in a 2, I get 2 minus 5, 5, negative 6. Let's drop it. I get a 4. I get a negative 1. I get a negative 2. I get a 3. I get a 6 with a remainder of 0. I'm really happy. So x equals 2 is a root. So this was an equation in x cubed, which means this equation is an x squared. So I get 2x squared minus x plus 3. And I'm going to factor this quadratic. I need to expand. There we go. So I'm going to use two numbers that multiply to 6 that add to negative 1, and I know that those numbers are a 6 and a 1. No, they're a 2 and a 3. So is that true? Two numbers that multiply to a positive 6 that add to a negative 1. I can't use a 2 and a 3. One of them has to be negative, and that's a positive number. I'm going to have to use quadratic formula here, guys. That's my last bet. All right, quadratic formula, the opposite of b. So a is 2, b is a negative 1, and a c is 3. The opposite of b gives me a 1. I do my plus or minus. I take negative 1 squared minus 4 times 2 times 3, and I put this whole thing over 2 times 2. Okay, so I end up with 1 plus or minus. Underneath here, I get 1 minus 4 times 6. This is 24. All over the number 4. So my solutions are x is equal to 1 plus or minus the square root of minus 23 all over 4. So x is equal to 1 plus or minus I read 23, the whole thing over 4, and I've got to go back and get my two other roots. X equals 2 is a root, and x equals 1 is a root. So I'm going to write down x equals 2 and x equals 1. Here I have two solutions. One solution, one solution. I have 4. I'm all set. So when we get down to this last spot, if you can't factor, I want you to use quadratic formula. That's what it's there for. All right. This is what I would like you to do for me for tomorrow. I'm going to have this answer up on the board. So I want you to find all the roots of this. And the first thing that you're going to have to do is write down all the factors of 12 and get ready to do some synthetic division. Have a good night.